Great. Well, thank you very much, everyone, for coming. This is the Online Trust Alliance, and we welcome everyone to our webinar, IoT Wearables, a deep dive into device security practices. Our guest speaker today is Daniel Miessler, Director, IOActive, and he has come to us to discuss some research about wearable IoT technology and security in this area. My name is Madeline Smith. I am with the Online Trust Alliance, and I think most people who are on this call are a little familiar with us, but if you'll give me a moment, I'd like to go over our background. The Online Trust Alliance is here with a mission to enhance online trust while promoting innovation and vitality of the Internet. We have a goal in general to help educate business, policymakers, and stakeholders, and that's the purpose of webinars such as this, the education and sharing information and knowledge, and moving toward developing, advancing best practices, tools, and enhancing protection of all users' security, privacy, and identity. The IoT supports collaborative public-private partnerships, and we're very excited to be able to share the information from outside organizations such as Mr. Miessler speaking with us today. As an overview of the Online Trust Alliance, in case you have been to our website lately, you would see that we are about contributing to a more trustworthy Internet, helping to protect data, businesses, and critical infrastructure, providing strategic insights, thought leadership and recognition, shaping public policy and best practices. We work in PR and outreach and educational events such as this. We have our Online Trust Alliance membership badge, which organizations that support us are able to use, and we run training sessions and educational efforts such as this. This is just a listing of supportive organizations for the OTA, and one of the things I apologize for is this is not 100% up to date at this point in time, but as you can see, we have a very broad range of support across many stakeholders and many organizations, and we're very excited about some of our most recent companies who've joined, including retailers like Target. We just brought on the National Realtors Association, which is particularly relevant for IoT and Connected Home. So we're very excited about the very broad range of organizations that support our organization. Further, we have collaborative efforts with other important nonprofit, governmental, or NGO organizations in all of these areas of privacy, security, and helping keep the Internet trustworthy. This session is to discuss the Internet of Things, and the IoT Trust Framework is one of the most recent big efforts from OTA in this space. We have a working group, the IoT Working Group, which recently published a draft trust framework, and we're currently in the request for comment phase of that. We published it in August. We're asking for public commentary, and we'll be accepting comments through this week. And the goal of that is to move toward a public-facing document of best practices with this wide range of input from different points of view and different stakeholders to help move the entire industry into best thinking and best practices around privacy, security, and sustainability in the Internet of Things environment. Coming up in November, OTA will be in Washington, D.C., doing an IoT cross-device tracking salon dinner and having our member group meeting. But today, we would like to turn things over to our guest, Daniel Miessler, who is Director, IOActive, who will be talking about research that he's been doing in security in this space. And I will be turning the screen over.
All right, can everyone hear me?
Great.
Great, good morning.
Thank you, good morning.
Good morning, all right. Well, as was said, my name is Daniel Miessler. I really appreciate the OTA having me here to have a conversation with you guys today. The topic is going to be IoT Attack Surface Mapping, which is a talk that I gave DEF CON a few weeks back. And just to give a little bit of background, basically, I'm currently at IOActive, but I spent the last 6 years running a security research team with HP. And we've done a few different studies there at HP around IoT, specifically focusing on consumer devices. The first research that we did was we basically went and looked at the 10 most purchased and common IoT devices that were available at like big stores like Best Buy and things like that. And we put them in the lab and we tested them using an OWASP testing methodology, which we developed and we now run the project for, which looked at devices across various different angles, right? At the time, we had 10 different dimensions that we were looking at IoT security in, and we subjected those 10 devices to that scrutiny using that system. And that was pretty eye-opening. We found some massive flaws on the web side, on the network side, and it was pretty eye-opening in terms of how bad it actually was. The thing we kind of figured out was that IoT security was basically a collection of network security, mobile security, application security, and cloud security, none of which we're actually really good at, right? We're pretty good at network security after 25 years or whatever, but all of these things combined, which is really hard to do well individually, when you combine them all together, it really gets exponentially worse. And that's what we saw when we did our first study. The next study that we did was 10 devices again, but it was 10 home security systems. What could go wrong there, right? Basically, we brought the home security systems, we installed them. That was door sensors, window sensors, importantly cameras. So put the cameras in different rooms and that sort of thing. Connected up the mobile app, connected up the cloud application, and from there basically said, well, okay, what can we do now? And what we found was that 10 out of 10, so 100%, were vulnerable to account harvesting on the internet side, which allowed us to break into the cameras, monitor the homes, see when homeowners were home or traveling or on vacation. So it was basically a wash. It was a complete compromise of the system in 10 out of 10 cases. So that was pretty disturbing. And then probably about a month and a half or 2 months ago, we released the smartwatches report, which also came out from HP. And there we looked at 10 different smartwatches and largely found very similar things. The focus there in this particular case was what kind of data are you putting into a smartwatch and where is that data going? So that's kind of the history that led up to this particular talk that I did at DEF CON. And the idea here was to say, okay, we started off with 10 surface areas that we used to test these devices, but I wanted to get a little more granular. I wanted to basically search for a holy grail or a universal set of attack surfaces for any IoT system, whether it's a car or whatever. So that's what we're going to talk about today. So the main question really arises when you're handed a device, and this is largely from a tester perspective or from a manufacturer perspective, right? When you are getting ready to produce a device and you're getting ready to release it, what do you have to do to test this thing effectively, right? So you have this random box. Let's say you're a tester. You have this random box, and you have to make sure that it's not shipped with any vulnerabilities, or it's already shipped and they're doing a pen test. How do you test it, right? That's the question. Or let's say you're handed an airplane, and they say, hey, make sure none of these systems are internet enabled and can't be compromised. What does that attack surface look like? When this thing is wired up to the internet and being issued commands from Siri or whatever, what does that look like? Or maybe it's a giant SCADA network or ICS network, right? What is the attack method? And unfortunately, it also applies to sniper rifles. Evidently, right before my talk, there was actually a sniper rifle that was hacked. So it was internet enabled, so it was pointing at targets and you could control the targets, but you could actually hack it and change the target. So that's super annoying and dangerous, and obviously something to be looked at. So the question is there a universal way to test a sniper rifle versus a toothbrush versus an airplane? Another concept I really wanted to get through was that the device security is not the security of the IoT ecosystem, right? There is an ecosystem. It involves the mobile. It involves the network component. It involves the cloud connectivity. And it involves all of these working together. It's a 1 + 1 = 7 scenario when it comes to IoT attack surface, because you can have an implicit trust relationship between one thing and another that complicates the risk and complicates the way to break in a very, very strong way. So lots of different current approaches to doing this in terms of finding vulnerabilities, right? Look at a common list of vulns and just kind of poke around and see if it has any of those. You can have your own favorite list and you just go through that. You could sort of brainstorm and think about bad things that could happen and test based on that. Or you could find like articles of where other things have been compromised and kind of test based on that. And these are all methods, unfortunately, that a lot of people use. It's just not comprehensive. So, like I said, we had a previous version of this project, which we called the OWASP Top 10 for IoT. And we use the Top 10 name because it's got a good reputation behind it. People intuitively like lists of 10, I think. Probably Letterman did that for us. But the problem is it created some confusion. Like if you're familiar with OWASP, OWASP has a problem with using a top 10 list maybe when it shouldn't be used. And really what ends up happening is you end up crossing vulnerabilities with risks, with threats, right? And it ends up being like, is this a list of, what is this a list of? Is this a list of problems or things or categories of problems, or what is it, right? So we had a little bit of that. We avoided it to some degree, but it still bothered me enough that I decided to change the structure. So the new structure for the OWASP IoT project is it's not the OWASP Top 10 anymore for IoT. It's just the OWASP IoT security project. And at the very top is the umbrella of the IoT project. And then the first project, which I'm talking about today, is the Attack Surface Areas project. Now, underneath that, you can see that we're looking at a whole bunch more. Testing guide, top vulnerabilities. There's also a really interesting sort of branch that's opening up now, which is implementations of correct ways to do things. So one really good example is, let's say, one thing we ding everyone on whenever we do an assessment is update system, right? So we say, hey, look, you're doing updates over FTP, you know, the backend server is world writable, you're not signing your updates, like all sorts of problems, right? And they say, okay, great. Well, what should I do? How do I fix it? And we're forced to say, well, I don't know exactly, but you can't do what you did, right? And that's not helpful to a manufacturer or to a developer. They're being told no, but they're not being told what to do for yes. So one thing we're going to have under this project is companies come in and build the right way to do things. Here's how you set up keys. Here's how you do certificate management. Here are the algorithms that you should allow versus others that you should not. And basically, ultimately, have something like a programmatic framework that they can plug into their product and have it be more secure, more by default. So that's kind of the overview of how we're currently looking at the OWASP effort. So now I want to talk about the attack surfaces themselves, and this is somewhat technical, but it should be pretty useful. So the first attack surface that is kind of like a meta surface is ecosystem access control. So if you think about an IoT system that has, 20 different components, forget 20, like what about 20,000, right? 20,000 different sensors and lots of different gateways and interfaces and all this sort of stuff. It's not only about how is that sensor doing or how is that gateway doing. It's about how do they work together, communicating amongst themselves and then out to the internet and from the internet to that system, right? Authentication, session management. Is there implied trust between some of these components that should not be there? How do you enroll a system into there? How do you take it out of the system? Decommission. What if one of them is compromised? Does it communicate to the central system that it's no longer trusted? These are questions that there's not really an approach to asking right now, so we have it explicitly in here. Next one is device memory. Some of these are very straightforward and clear. Device memory as its own surface area, so clear text usernames, passwords, credentials, keys, that sort of thing. Device physical interfaces, so this one's really big, right? Those of us who've been in security for a long time, we know that physical access is often the end of the game, right? If you have physical access, you can oftentimes get root. So that's why you have cages and all sorts of things to control physical access. So firmware extraction you could potentially do from a port, get a user level command line shell, admin level command line, privilege escalation, reset to a default and just start over and put in your own settings. Lots of different options for compromising security once you have physical access. Next one is the device itself. Let's say this is a sensor, or let's say it's like a router or something consumer oriented. It's often putting out its own web interface, right? That web interface itself, whether it's on 20 different sensors or it's on just this one central device hub or whatever, could be vulnerable to all sorts of common web vulnerabilities. SQL injection, cross-site scripting, the whole list. So that's one thing you definitely have to look at. There's also the firmware that's on the device, and this is oftentimes related to the physical access, but you can oftentimes get it somewhere else, right? Oftentimes you can just download the firmware, do a bunch of analysis on it, find out it's got hard-coded passwords, pull out URLs, pull out encryption keys, all sorts of stuff you can do just by having firmware. Device network services. So that device, let's say it's a router or something of that nature, are often listening on various ports. And those ports can sometimes give you information about what the device is doing or what its configuration is, stuff like that. Or in some of the cases in the research that we did, we were able to connect to a port and it dropped us right into a root shell with no password. So it was like root is the username, password was blank, now we have a root shell on the device. So this is definitely something that needs to be locked down. Administrative interface. So this is another interesting one that's not really found anywhere else. This is, let's say you have the device and you have sensors and you have the cloud interface, but there's also a separate interface. So imagine like a SCADA system or an ICS system where you not only have the stuff that's deployed, but you have a separate controller or thick client or something of that nature, which is back at the control station or whatever, where you could fire this thing up and go and control the gateways or the sensors or flow from here to there, whatever it is. So the key thing here is to remind manufacturers, to remind testers that it's not just individual web interfaces or individual cloud interfaces. If there is another way of administering this system, you have to test that as well. Next one is local data storage. So if you could pull a device, whether it's a sensor or a router or something of that nature, and it's got stuff stored You can often pull log data and all sorts of content off of that system. Cloud web interface, separate from the device web interface, separate from a potential separate admin interface. This is specifically the interface that faces the internet. And for IoT, I'm telling you, this is a really, really big deal. Because when you search on a search engine like Shodan, which can show you just what's live and listening right now, and you can have a brand new vulnerability come out, and you can say, oh, wow, I found all 29,000 devices that are currently vulnerable to that right now. It's like it's a dream for an attacker. Well, they're coming in through this interface. And this interface often ties directly to the internal functionality inside the house or inside the enterprise, right? And it's vulnerable to the exact same web issues that people are having massive trouble fixing all over the place. I've spent the last 10 years doing web application penetration testing, and these problems are basically not going away. Some of them are getting better, but it's remarkably easy to find problems with weak passwords, no account lockout, and being able to just brute force and grind through it, pull out credentials that can allow you to compromise the system. So cloud is really, really important because it's the part of the IoT that's the I. It's the internet-facing one. So this is another cool one, third-party backend APIs. So one of the things that we found in all three of our studies was that when you put data into a device, you don't really know where it's going to go. People think they do. People think that you put in your whatever date of birth or your application data or whatever it is. They think it's going out to the approved backend and it's probably using SSL and it's talking to that one good backend host that belongs to the vendor. Not true. Often what happens is it's going to lots of different third parties. And oftentimes the third parties are things like ad networks and analytics networks, and the content is being sent unencrypted. So you have one connection going to the legitimate back end, and that's encrypted. And then you have 5 other going to non-approved, or at least you're not aware of where they're going, and they may or may not be using encryption to protect your data. So this is a really interesting separate surface area to look at. Update mechanism. This one is massive. So I talked about it before. We had scenarios, lots of scenarios in our 3 different studies where we had updates being done over FTP. The username and password was set in the clear. The update server where all the software was stored for the company was world writable. So we could just create new software, write it, name it, whatever the server side or the client expected it to be, and someone would just come in the next few seconds and pull it and download it and install it. And the content wasn't even signed. Not only that, but it wasn't just the software for the device that we were testing. It was the software for all products made by that company, right? So serious, serious problems here. And as we know with IoT, when you're deploying billions of devices, which we're about to, if you can't update those systems when they become vulnerable, which they inevitably will, you're going to have a big problem in the future. So update system is just massive. The mobile application. For the consumer side, you hardly ever have an IoT system that doesn't have a mobile app. And oftentimes that mobile app has the ability to control that system, right? Otherwise, why have it? And the real question is, how is that mobile app authenticating to the system each time? Is it done once in a really secure way and now it's easily spoofable? Is it done each time? Is it not done at all? Plus, is there data moving around from the application that's now being stored insecurely on the mobile application? So there's lots of different considerations there with the mobile app. Now, vendor backend APIs. So this is differentiated from the third-party backend APIs. So the vendor could be a legit location to send it to, but is it being done securely, right? We see a lot of connections going back to the legitimate backend that are not encrypted, even if they're doing separate connections to third parties. Finally, or almost finally, ecosystem communication. So let's say you do have a 20,000 node IoT network, excuse me, and you have lots of different communication. You would expect this large ecosystem to be, talking to itself, right? How is it doing health checks? How is it doing heartbeats? How does it know if that sensor, its battery has died, and maybe it's not there anymore? What does the heartbeat look like? Is it authenticated? Is it encrypted? What if someone digs into the ground, pulls up the sensor, writes their own software, installs the software on it so they can backdoor and move around the ecosystem and pull data and send it out? Who would know? How would we know, right? And if it was compromised, if it were to be compromised, how could we exclude it from the system? How are updates pushed to 20,000 different sensors, right? This is the communication framework for a large ecosystem, and it has to be looked at separately from devices or any of the other surface areas. Finally, network traffic. The traffic that's moving around, especially in a very large network, there's just tons of it, right? There's the LAN network itself, there's the traffic that's going out to the internet. There's also short-range protocols, Bluetooth, non-standard protocols, especially in IoT, it's the Wild West. You got people making up a new protocol every 20 minutes. Are they using encryption? How are they authenticating end-to-end? What algorithms are they using? These are all things that have to be looked at. So this is what we end up with. The current form, and to be very clear about this, this is an OWASP project. It's myself and Craig Smith, who has been on my team at HP and our security research team. And we're the ones putting this together. And this is our list based on what we think, based on our experience with pen testing. But this is an OWASP project. If someone pings us and says, hey, ecosystem communication could be combined with this other one. Oh, and you forgot this one, which applies to airplanes. And I'm like, well, I don't know much about airplanes, so I guess you're right. So the point is it's a living set, right? This is adjustable. I wish this thing wasn't lopsided, actually. I mean, I'd like to add a couple more. But this is why we didn't do the 10. The 10 artificially restricts you down to, collapsing things that should not be collapsed. Or let's say there were only 7, we try to get to 10, so we're breaking out ones that don't need to be broken out. What I decided to do in this one is just let it happen naturally, right? Define the surface areas and you end up with a crazy number like 13, so be it. So definitely anyone on the call has feedback in terms of, hey, you forgot this one, or you can combine these down, or number 17 is dumb, whatever it is. Definitely feel free to reach out to us. So this is the project, Attack Surface Areas project, and it is under the IoT project. Here's some of the things that we're basically going to allow people to do with it, right? We'll be able to say things like, in the local data storage surface area, we found X vulnerability, which compromised data type of this, and remediation is this, right? So we can really provide a framework for understanding the category of the problem, combining that with the specific vuln that could be exploited, and move into remediation. So I think I'm going to skip this part. Basically, I wrote a tool. Yeah, so people think they have this in terms of a network connection. They actually have this. Their data is going all over the place. And I wrote a tool called Caparser, which anyone, of course, is free to go and use. That's the URL on GitHub. But basically, you can do a packet capture on the network, and this will automatically parse all the content that's being sent out in this PCAP. It will isolate all the different hosts that the data is being sent to, and then it will look for sensitive keywords inside of that content for each destination host. So it'll tell you, why do you have the word password or Wombat27, which is fake application data that you entered into the app. Why is Wombat27 seen being going to badhost.com, located in wherever, Shanghai, right? So that's what this does, is it automatically parses stuff for you and tells you if there's a hit with clear text data going out to the internet from your IoT system. And that's the URL. It's really easy to do the packet capture to get this stuff. It's a $180 device on Amazon. And there was a demo, but I'm not going to do that. And I think that's pretty much it. I am the Cavalry, build it securely. Obviously, this project here that we're talking about today. And I think that's it. And I'd like to open it up to questions.
Thank you very much, Daniel. A couple of questions did come in while you were speaking, and one of the things that I wanted to ask about, and perhaps this link that you're providing here is part of the answer to it, but early in the presentation you talked about some of the actual vulnerability reports that have been presented or that you've been able to present at different conferences or areas, and one of the attendees was asking, are those reports proprietary or internal to certain organizations, or is that something that any of us who are on this call could go find some of the actual results reports?
Yeah, no, they are all open and out there. So if you do a search for HP IoT security research or some combination thereof, and I could also send the links to you guys to distribute to people on the call. That could possibly be easier. Yeah. Yeah,
that would be fantastic. Another topic that I just wondered if you had additional, since we do have a little bit of time, if you'd like to explore or widen a little bit. You make the great point. There's so many great points about the potential risk and the sort of different surfaces that could be exposed. But in particular, the question came in about on the vendor backend. There's a concentration here just on your slide, and I'm sure part of it is just space, simply the API side. But really, the question came up: have you found the entire sort of vendor landscape and their own environment itself, not just simply the API, but the entire environment that exploit vulnerability in that area? You kind of hinted at it, and I wondered if you had more thoughts about, as data gets connected to or handed off, the exponential rise in risk.
So are you saying like the insecurity of vendors who are making these products? Is that what was being asked?
Possibly. It was just the general sense of, aside from the specific connection, API, but just the entire vendor environment being exploitable, and whether that's something that you've had research into or examples of, or other concerns that we can take away to think about how to come up with best practices of the connected landscape.
Yeah. So one thing I would say that's pretty clear is that vendors need a lot of help. This is why the Build It Securely project with Mark Stanislav and Zach Lanier, they came out with their effort, because, and it's focused on very small companies, like startups basically, who have no security people whatsoever. It's like one or two devs, and they're pumping out this product. They're getting ready to release it. And what they do is they pair up with a security researcher to try and get their product tested before it goes live. So it doesn't scale very well, but it's extremely helpful, because you have to pair up a researcher with a company and stuff like that. But it's the need is so there. It's just unbelievable how much need is there. I've talked to, and obviously there are no names, by the way, in any of these three reports. It talks extensively about the vulnerabilities that were found, but it doesn't say, it was, Acme router that we found the vulnerability in, just because, everyone on the call knows the whole responsible disclosure and everything, and plus being HP, they have very low tolerance for being sued by their potential customers. So that's not something that we were going to release. But the thing about it is, a number of companies that I've talked to, I get on the phone, and these are extremely large companies, and they're like, hey, look, so here's the thing. I just got hired yesterday, and I've got a portfolio of a couple thousand apps and or products, IoT products, and we've got to release them, but it's just me here, and I really need some help. I have no idea what to test or how to test it or what I should test first. And I'm like, wow. Like that, they don't have a, they're at step 0 or whatever's less than 0 because, and that's not all of them. There's a band, right? There are some companies that have a larger team and they have, you know, more secure practices, but a lot of situations it is really bad on the vendor side because they're just now realizing a lot of these vendors have been making analog things, meaning not connected to anything, for years and years and years, and for them to switch in a matter of months, basically, to being internet security experts is a really hard thing to ask them to do, especially when being a web security expert is hard, being a mobile security expert is hard, being a cloud security expert is hard, and now you're going to ship an IoT product that requires you to be an expert in all of those.
All three, exactly. Kind of related to the conversation you just had, only going back to the OEM side, the question came in, sort of, was it part of your research projects to reach out specifically to affected OEMs or service providers on vulnerabilities you found? And then the further expansion of that question is, what did you find the responses to be in general? Do you feel like immediate action steps being taken? Oh, yes, great, let's improve. Or do you have any sense of that, or would you like to comment on that?
Yeah, absolutely. So we did do a formal reach out to each company entity that we found vulnerabilities in, and we track all the responses. And it got better through the 3 reports, right? The first one we did was quite a while ago. We got into this, I guess, in early 2014. And we didn't get much of a response on that one. We got more on the second one and a lot more on the third one. So the visibility is sort of picking up, and the interest and the, I guess, staffing and attention is picking up. But even then, we saw a scale. We saw a couple of people saying, very few, 1 or 2, who said, why are you looking at this? Bah, get off my lawn. We had that a couple times. The vast majority, or I would say the next biggest majority would be not much of a response at all, like just a dead zone. And then we had a good portion, especially in the latter 2 reports, that were like, oh, wow, this is super cool. I'm glad you contacted me. We got that fixed immediately. You know, thanks so much. So very friendly neighbor sort of attitude. And, yeah, so it was a perfect mix, all the way from get off my lawn to thank you, neighbor.
Great. You know, I did want to put, we had someone raise a hand who would like to speak a little bit, and I think this is, we kind of moved beyond it, but this is in the question around the vendor environment and not just APIs and the discussion that you just had. My camera, are you on? And we're going to unmute
Yes, I am.
if you'd like to. Great, great. Well, welcome, and we've got you unmuted, so now you can discuss.
So, Daniel, I was the one that asked the question about the vendor space. So, as a side project, not my day job, for the past, going on 5 years now, I've been doing some exploration in the ICS and agriculture space. I've done a few presentations in closed groups because it's kind of sensitive. So this would be precision agriculture and whatnot. And the reason that I asked the question was, every year I go, one of the events I go to is Farm Science Review. It's actually coming up next week, and it has hundreds and hundreds of vendors, many that are doing precision agriculture. And so what I did a few years back after I accidentally owned a combine in doing some research is I looked up the address spaces of the companies that are working in that space, and I did some scans just to do banner grabbing, and it's amazing how many of them are using older, vulnerable versions of software. And so one of the companies, a marketing brag was they could do updates of their software in the field on the fly, and I had a strong notion that I could do updates of their software in the field on the fly.
Yeah.
And so that's why I asked the question about any insights you had about, instead of coming through the APIs, coming around the other way, and either grabbing information and or working backwards to do things to the devices.
Yeah, no, it's interesting. So I think that it all depends on who the attacker is, right? You have basically different threat bands, I would say, where it's like, you know, a random person who has 11 minutes to spend and barely knows how to use Nmap. They're going to do whatever's super easy and someone else has already written for them. And they definitely would not be compromising an internal organization so that they can compromise their IoT systems. But let's say, given your example, let's say that's a SCADA system or an ICS system, and let's say it runs the power grids for the northeastern United States. A state actor absolutely will go and compromise an internal company to gain knowledge to be able to control those systems. So I think you're absolutely correct. It's just a question of what type of space are they in that makes it worth it to do that.
Well, I could think of interesting things in the consumer space.
No, I think there is some overlap, but yeah, I agree. Well, I'll give you an example. So I've done a bit of government consulting with a bunch of three-letter groups, and they were asking, like, what are some abuse scenarios? And I thought of one where if you can issue a command that only controlled power, right? You could only turn something on or turn something off. But what if you could control like 45 million of them or something, right? It was just like a toaster being turned on. Well, what happens to the power grid when you turn on 45 million of anything all at once, right? So it could be something extremely low level or seemingly not too dangerous, but done at scale or done in a certain way could cause a major problem.
Right, exactly. Mike Hammer, I'm going to actually put you on mute again just to be even-handed about everything, but if anyone else would like to comment or speak out loud, please just alert me with the hand raise or the question panel. But
yeah, I think it was a great question.
Otherwise, I think we are going to wrap this up. So Daniel, thank you very much. I'm going to take us back to the OTA closing screens. And here we are. So just as kind of a wrap-up reminder, first of all, thank you again very much, Daniel Miessler, for sharing the research that you've talked about. We'll look forward to making your slide deck available, but also if you can send us the links to the actual 3 reports that you discussed, that would be fantastic. Everyone, there were multiple hand raises on that, people being interested in that information. And OTA will make that available. I just wanted to wrap up with everyone who's attending. Thank you for your time, and this slide is some of the resources that are available on the OTA site that you can take a look at. Of course, the IoT Working Group, which is the sort of host sponsor for this webinar. We have information on email integrity and security. We have an initiative around public policy. There is, of course, the OTA Online Trust Honor Roll. And our email integrity audit. And if anyone needs anything, please feel free to contact us at otalliance.org and the phone number on your screen. So thank you, everyone, for your time and attendance.
All right. Thanks so much.
And it's been great. Thanks very much.